So hello, I'm Giorgos from Fourth, and I'm going to talk about the work and the integration that takes place in the EUPEX project. The title is Using Flash for Intermediate Data Management in HPC Applications. So nowadays model simulations such as weather or physics produce a large volume of tracing data that are produced concurrently from thousands of compute nodes. And the important property for them is that there's need for immediate indexing for this data for near real-time analysis, because they are consumed by post-processing tasks concurrently as the simulation is executing. So there is this immediate need. Now, traditional parallel systems such as Saloustros, which we find in HPC facilities, have not been designed with this in mind. For example, there's no efficient index mechanism in the file system due to the known problems of metadata. And now the opportunity is that flash memory provides the IOPS and the latest needed for this intermediate data management. And we need to figure out the proper software stack to expose it, but without disrupting or rewriting the HPC applications. Now, a little some info about the weather application that we used. This is the weather application from ECMWF. It's an application. It's a weather simulation that runs in thousands of compute nodes, roughly 4 times a day. And the important thing is that there are tight time constraints for prognosis. The main idea is that the atmosphere is split into tiles, and each tile consists a lot of metrics regarding various stuff like temperature, pressure, or wind speed. Now, for this purpose, ECMWF have built a custom database solution, which is named Fields Database, and is implemented on top of POSIX file system, Laser in specific. The projection, according to ECMWF, is that both tile count and metrics increase over time because their models want to achieve better accuracy or capture some other properties. So the projection is that these intermediate data are increasing over time. Now, the question is how to use Flash in this application. The answer to this question is to introduce a Flash tier in the HPC facility between the compute nodes and the Laser file system. So this Flash tier consists of data nodes which are equipped with mainly with NVMe SSDs. This Flash tier is integrated with a SLAM scheduler, so it can provision storage and allocate flash resources per job, and do the entire life cycle management per job. So it does the cycle for provision, use, and then release. Now, on the second part is the indexing, the indexing challenge. So we need to ingest data at very high speeds, order of tens of gigabytes per second, and we must create a searchable index during ingestion. Now, this index must work efficiently regardless of the I/O sizes and the data size. We should control the traffic to flash. This is the right amplification. And reads must remain fast even when executing in parallel with the ingestion phase. So the dilemma: first of all, POSIX file systems such as Laser are not designed for this kind of workloads. And also, if you want to add custom index in the application, adds more complexity. And now we can use a standard recipe from the bibliography such as B-trees, which SQL databases use, but they have high write amplification, and which is poor for Flash because it kills endurance. So we find the answer from the successful recipe of the cloud world, which are the LSM trees. So in the cloud world, the LSM trees power the whole cloud infrastructure. All the major hyperscalers use this technology. Major systems include Cassandra, RocksDB, LevelDB. Now, the important property with this technology is that it guarantees always large IOs in the order of megabytes, regardless the IO pattern. And it achieves this briefly via batching of writes in memory and the constant reorganization of the data among levels, which is a process called compaction. And the important thing is that you have the ingestion is pretty good with this technology, and the reads are efficient and are comparable to a B3. In the EUPEX we designed the parallax key value store, which uses at its core this kind of technology. It has some, it applies some reorganization strategies which exploits the object sizes to control the right amplification, which also has major gains, especially for large objects. And currently we support high-speed interconnects such as InfiniBand or BXI. There are currently two deployment modes. The first deployment mode is to run the parallax service collocated with the data nodes, as we see in the left part of the figure. And the second is to run parallax KB service in the compute nodes and expose storage as NVMe-OF targets. Now, this is some really preliminary evaluation. We're going to do a full evaluation in the last year of the EUPEX project, where we stress FTP with small requests in a host, and we see in the x-axis the execution time, and in the x-axis the two configuration. Result seems promising, but we need to perform now a large-scale evaluation. So I think I was fast, right?
Great presentation, thank you. On one of the last slides with the two possibilities for the placement of parallax,
yes.
Could you elaborate a bit on the pros and cons of each one of those placements, please?
So the first option is to deploy parallax in the same data nodes that are hosted devices. So the compute nodes access is over a custom RDMA protocol, a custom network protocol. Whereas the second is you can provision storage and expose it via a standard storage protocol which is called NVMe-OF, and run the parallax store in the compute nodes. The second option is if the CPU, if the workload is bound from the CPU, you can scale the parallax instances to more CPUs.
Okay, understood. Okay, makes sense. Thank you for the answer.
Yes. Also, next slide.
This one?
This one.
Yes.
Have you figured out to add a third measurement, or just on a luster file system?
No, this is not. This is in a single host without with a local file system, not with luster.
I mean, with luster on a single namespace and with SSDs and flash devices, just to figure out what is the gain about getting rid of MDS and blah blah and POSIX.
Yes, of course.
Because NVMe, we have figured out in having a level 0.5 instead of level 1, but always in procurement we say, okay, there is benefit, but not enough for this infrastructure. So have you tried to make this difference? Because
yes, we plan now to, in the full-scale evaluation, to perform all this.
Yes, okay.
So by the end of the year.
Yeah, I mean, this is something that you can achieve during 2026, full-scale evaluation.
We must achieve.
Okay, okay.
It's planned on record. Okay.
Okay. Thank you.